Algebra 1, linear function. Simultaneous linear function. We are going to learn about simultaneous function, but before that, we deal with equation. What is equation? Let's review a little. Equation is 3x plus 5 equals 20. You have an unknown value, and you determine unknown value by solving equation. It's not function, okay? Function, you need to have two unknown value. Those unknown value are called variable. And one is the independent variable, another one is dependent variable. Okay, so that's the function. Now equation has two unknown it has an unknown value. When you have two unknown value, we call that simultaneous equation. And this linear function, the first question is, do we have two different unknown value? Can we solve for those? Here's example. Suppose you have a point A, x1 coordinate, right? Point A and B. And linear equation go through A, B. We know how to make a function for this. And we have a C, linear equation going through B and C. Okay, so two linear equation, the two linear equation is going to cross at the point B. Okay, so if somebody asks function, the first function A and the second function B, what is the value to satisfy function A and function B? You have two equations. Then just like you solve the equation for x unknown value, we can solve for unknown value x and y, which is this coordinate, right? Point B is going to be on this line and on this line. So this combination of value x2, y2, you plug in, equation is valid. And you plug in same set of numbers, this equation will be also valid because this point is sitting on the both function. So that is a solution for the simultaneous equation. Okay, let's just see the example. Find the linear equation that satisfies 2 points below. Find the coordinate that will be on both lines. Okay, the 0, 3, 0, 3, and the 3, 0 here. So first equation is y minus equal minus x plus 3. See, this is the intercept, y-intercept, right? Okay, now next one is 3, 0, okay, same point, and 0, 1, 0 or minus 1. So this equation is going to be slope is 1/3 x minus 1. Okay, so if you say the unknown value x and y that satisfy both 1 and 2 equation, okay, that's the solution for this simultaneous equation. Okay, so two function 1 and function 2, the function xy is sitting on this line, function 2 sitting on this line, and which value satisfies both this intersection, right? Which is 0, 3. Okay, so in order to create simultaneous equation, you need two linear function, because each linear function has so many possible value, and two of them provide only one value that satisfies both. So that's a simultaneous equation. And if you solve this, you can get the single value of x and y. For this example, 0, 3. That's the answer for simultaneous equation. Okay, let's look at another example. Common point: two lines cross at the point A, B, C, D. Okay, AB gives this one. And CD give this one. Okay, so there must be some point crossing. So if you make it a simultaneous equation, you need a two linear function, right? And how do you make a linear function? For the first set, you know m first set equals x2 minus y2 minus y1 over x2 minus x1, right? And you know how to calculate the intercept. So you can have m1 x plus b1. Second set, we do same thing and create linear function m2 x plus b2. Okay, so there is only one value, say x5 with y5. This is x5 y5. That's, you plug in this, valid, you plug in this, valid. So this is going to be the simultaneous equations solution, right? So find the simultaneous solution to the following two lines. For example, this and this. Solution to the simultaneous equation, write the answer below. So how can you find out? You make equation this and equation this. Well, this is easy, right? Because if you say both are equal, then minus x plus 3, this guy, should be equals to this guy, x minus 1. Okay, so you move the x this side, so x plus x, and move this guy over here, plus 1. So 4 equals 2x. You divide both by 2, x equals 2. Here, x equals 2. Once you know the x, then you can calculate y easily, right? Okay, so somehow we can solve simultaneous equation now. So if you have a two unknown value, you create question, two function, and solve it. Then you get two unknown value. Okay, now here's an example how you do it. Okay, simultaneous equation solve linear problems. Okay, SUB's current supply level is 5,000 units per month. Okay, As a price increase, the supply of SUV will increase at the rate of 500 units per 1,000. SUV are very popular and demand is now 10,000 units per month. But the demand will decrease as the price increase at the rate of 300 units per 1,000. What will be the price of SUV after the market settles at the balanced level between supply and demand? So this is a famous supply and demand curve, right? And in this model, demand decrease as the price goes up, and supply increase as the price goes up, and this is number of unit. Okay, so supply linear function is number of unit is 500 x plus 5,000. X is $1,000. This is a unit we use. So each $1,000 it's increased 500 unit. Okay, and starting with 5,000 unit. Demand's linear function is number of unit is going to be, you see the decrease of 300 unit for every $1,000, and starting with 10,000 unit. So you have a two equation. Where is this settling point? That's gonna be market steady point, which is price is just about right. For the demands, supply and demands become equal. Okay, so you don't want to sell at the high demand and the price is lower, or oversupply, demand is slow. Okay, you cannot sell this case. This one is inventory become empty. Okay, so you solve this equation, you get steady point, solving another problem. Two cars left point A at the 45 miles per hour toward B. The train left point A 2 hours. This question two, not two cars, one car. Okay, so you have point A and moving to point B. The car is 45 miles per hour. Train left 2 hours later toward B at 90 miles per hour. Train is faster, right? But 2 hours later. So where can the train catch up the car? Well, we make a two linear function. Okay, the distance, the train is faster, slope is higher, but 2 hours later it start. Okay, x is hour, number of hours. Okay, y is a distance. The car start moving from 0 all the way at the 45 miles. So you make an equation, the function distance of the car is 45x number of hours, but train is y times 90 miles per hour, but you have to subtract 2 because 2 hours later it started. So now you have a two function, car and the train. So if you solve this one, you can tell x, well, how many hours it takes for train to meet the car, right? Okay. Now we talk about how to solve simultaneous equation. It's kind of a subject is kind of contain too much here in this video, but you have to You can take a rest and come back, but this is important. Now we talk about how to make a two function and create the simultaneous equation to solve x and y. Here's the systematic way to solve. Okay, assume one linear equation is this a, another equation is b. Okay, instead of y equals mx plus b, we use this form, y minus mx equals b, and more general is a1 x plus b1 y equals c1. Okay, so we have this form. Multiply b by a1 over a2, so the first equation becomes like that. So then this becomes same, right? The b become this way. Coefficient of x is same as coefficient of this. So you subtract left side. You subtract the left side from this left side. Okay, use a different color. You subtract this left side from this left side. You know this is going to disappear, become only y. Okay, and subtract this right side from this right side, which is this. So you have only y left. Then y equals whatever this coefficient and this c1 minus c2 a1 a2. Okay, so you can eliminate one of unknown value by aligning a coefficient. Aligning coefficient, this is important. Align coefficient. Step 1. Step 2, subtract and eliminate one unknown value. Okay, that's why called elimination method. You can eliminate one unknown value by this method. Okay, so here's an example. The using a general coefficient may confuse you, so let's look at the example. 3x plus 5y equals to 2x minus 4y equals 6. So we change this, we multiply by 3 over 2, so it's become like this. Okay, and you subtract this, both this 3x become common, so it's disappear. So 5y plus 6y equals to minus 9. So you solve for the y, you get the answer. You put the y back, then you get the x. In the elimination method, we align the coefficient of one parameter, eliminate it from the equation as you see in a minus c. If we want to eliminate y first, we can multiply different coefficient ratio. You can eliminate y either way. Okay, eliminating one unknown variable by aligning coefficient and subtract, that's the elimination method. Okay, so here there is a one more method, substitution method. Somehow it's forgot to include that. We talk about that later maybe. Special solution for simultaneous equation. There is a case that you cannot solve equation. For example, if line is parallel, what's happened? There's no crossing point. That means there's no solution. You try to solve it, it's impossible. For example, this one. y equal minus x plus 3, y equals also minus x. Would it be possible? There's no such a x and y, so there's no solution. Okay, another case. When two functions are identical, they are identical means two lines are overlapping. Okay, that means cross point is everywhere. So any combination of x and y satisfy both. So this is the case that the indefinite solution means the answer is indefinite number of answers exist. Any value sitting on this line satisfy both. Of course, they are same. But if somebody give first linear function by this pair and this pair, it doesn't look like it's exactly same overlapping function until you draw the graph. Then you notice, aha, this is the same equation, right? So when you see those coordinates and say, well, one function goes through this and this, another one goes through this and this, they don't look like they are the same equation, but once you solve it, you find out it's the same equation. Then the solution is indefinite. Okay, so there are two cases, special cases. The solution doesn't exist, or solution, the answer is indefinite number. Okay, so that's something you have to pay attention to. We skip one thing, substitution method. There is another way to solve the simultaneous equation beside elimination method. Okay, I think we will cover that in the next video. Okay, thanks for listening.